Hello friends, welcome to Data Science Lovers. In this video, we are going to analyze a real salary dataset with more than 22,000 rows. We will explore the data, clean it, remove the outliers, and visualize the trends. And finally, answer the most important business questions like which company pay the highest salary, which cities offer the better pay, and does company rating affect the salary? By the end of this video, you will clearly understand how a complete data analysis project works from start to finish using Python. Here we are in this Jupyter notebook and about our salary dataset. This dataset contains the real world salary information which is collected from multiple companies across different locations. It is designed to understand salary trends, pay distribution, and factors influencing compensation in the job market. Okay, and as I told you, this data set contains about 22,000 records, which is suitable for our exploratory data analysis, data cleaning, visualization, and getting the business insights. These are the questions we have, and we will use Python language to answer these questions. Let's start with importing the required libraries in this Jupyter notebook. We will import the pandas library, import pandas as PD. We will also import the numpy library, import numpy as np. We will import the matplotlib library, import matplotlib dot pyplot as plt. And we will also import the Seaborn library for visualization. Import Seaborn as SNS. Now we will reset our matplotlib library style dot use and here default. By this line of code, here I am using Matplotlib's default style to keep all the visualization clean and easy to understand, and it is especially for beginners. Next, we will set the Seaborn context sns.set context, and here you will set it is as notebook. Okay. It will tell the Seaborn library to adjust the size of the text and the plot elements like labels, titles, ticks, and lines so that the plots look perfect inside this Jupyter notebook. Moving to the next part, we will load the dataset in this Jupyter notebook. Our dataset is in CSV file format, so the syntax we will use is pd.read underscore CSV, and here we will paste the path of our file. We will go to the folder, this is our file, we will copy its path and paste in our Jupyter notebook here. When we will run this, it will show an error. To remove this Unicode error, you have to simply write small r here and run this again, and this is our dataset. Okay, you can store this in any variable. I am naming the variable name as df, short form for data frame. So this is our dataset. Here we have 22,000 rows and 8 columns. Now after loading the dataset, let's see some basic information about our dataset. So here is the dataset. By default, it is showing top 5 rows and bottom 5 rows. Let's check the shape using the shape command. It is showing that this dataset contains 22,770 rows and 8 columns, which is also mentioned here. We can also check the basic information about our dataset using the info function, df.info function. Okay, this is the range index, and as you know, the index starts from always 0, and here it is showing we have 8 columns. These are the column names, and in this dataset it is showing how many null values are there in each column. So the value, or you can say element in each row, is about 22,770. Okay, means there is no null value in our dataset. It is a clean dataset, and it is showing the data type for each column. And float data type, we have 1 column. For integer data type, we have 2 columns, and remaining 5 columns are of object or category data type. We can also use the describe function to get some more information about this data. df.describe function. It is showing the, you can say, summary for numerical columns like ratings, salary, and salaries reported. In case you want to check summary about the categorical column as well, then you can write a parameter here which is include equal to all. It will show some more summary about the categorical column as well. Now the next part is cleaning our dataset. In this we will check for any missing value in any column, and the syntax will be our data frame name dot is null function. On this function we will use the sum function to get the sum of missing value. Now for each column it is showing 0, means there is no null value in any column. As I already told you that this is a clean data set, and we also check this from here also. Next step in cleaning the data set is remove the duplicate rows from the data set. And to remove the duplicate rows, we have a function known as drop duplicates. We will write our data frame name. On this we will use drop duplicates. Okay, when you will run this, it will show the output, or it will show the dataset after removing all the duplicates values. But here it is showing the actual number of rows, means in this dataset we don't have any duplicate row. Okay, but in case if any dataset you have duplicate rows, then you can run this syntax, run this command and save this again in the actual data frame df. Okay, and you can run this again. After cleaning the dataset, we will check for the outlier in this dataset and remove the outliers. So here we will draw a box plot for our salary column. To draw the box plot, first of all we will set the size of our figure using the figure function from Matplotlib library, and here we will pass the parameter fixed size, and let's choose the size as 6 by 4. Then we will use the Seaborn library to draw the box plot sns.boxplot, and here we will pass our column name data frame, and inside this we will pass the column name as salary. Okay, we can also give the title. Okay, let's first draw it, the box plot. This is our box plot. Here I am giving the title to this box plot, plt dot title, and you can say salary outliers, plt dot show. So this is our box plot. In this box plot we can easily see the distribution of salary using the median line, which is here, this line, and here we have quartiles, quartile 1 and quartile 2, and then we have whiskers, or you can say range. Okay, and the main point is outlier, the point outside the whisker. Here we have the whisker and this one is the outlier. We will remove this outlier of salary column. Okay, we can say that this box plot helps us understand the salary distribution and easily identify the outliers. Now we will remove this outlier using the IQR method, means interquartile range method. It is most commonly used statistical techniques to detect and remove the outlier from the dataset. In this we have to set our Q1, means 25th percentile. It is a value below which 25% of the data lies. As we have to remove the outlier from salary column, so we will consider the salary column here, and we will use the quantile function, and as we have to write the Q1, means 25th percentile, so we will write 0.25 here. Similarly we will set our Q3, means 75th percentile, and it is a value below which 75% of our data lies. So again we will consider our salary column, and we will use the quantile function again on this. This time we will use the 0.75 because this time we are mentioning Q3. After this we have to find the IQR, and it will be Q3 minus Q1. Okay, I will run this. Now we can set our lower limit and upper limit for the outlier. First of all, let's set the lower limit. To set this we have to use Q1 minus 1.5 and multiply by our IQR value, IQR. Okay, similarly we can set our upper limit equal to, here we will use the Q3, sorry, and here plus 1.5 multiply again by our IQR value. So any value below this and any value above this will be considered as an outlier. We will run this. Now we have to filter our data set with respect to the salary column. For this we will consider the salary column, and here we will choose the value which are greater than our lower limit. Okay, this is our first condition, and we will choose the value which are less than our upper limit. Okay, again we will consider the salary column, and this time we will have to consider the value which are less than the upper limit. This is our second condition. We will put this in the round brackets as well, and we have to satisfy both the condition, the first condition and the second condition. So we have used here the AND operator. Now we will put this in a square bracket and df. Okay, and we will save this in our actual data frame df. Okay, it is showing an error. Okay, the error is we have to use the underscore here per limit. Okay, the command is executed. Now we have a look at our data set. It is containing now 21,614 after removing the outliers. So that's how we can detect and remove the outliers using the IQR method. Next, in this project, we will do the univariate analysis. Univariate analysis means analyzing only one variable at a time to understand its distribution, pattern, and behavior. For example, in this dataset, we can analyze the salary distribution, we can count the job roles, or we can check the ratings. It helps us to understand the distribution and behavior of a single column, like salary, as I mentioned, without comparing to the other columns. It can help in getting answer like how our data is spread, what values occur most often, are there any outliers in the dataset, or is the data is skewed or not. The one thing you have to notice is in this type of analysis, no comparison is done with other columns. Let's do it for the salary column by drawing a histogram using the Seaborn library. Let's set the size of figure using the figure function plt.figure. Fig size equal to, I am setting it as 8 by 5, 8 comma 5. Okay. Next we will use the Seaborn library SNS to draw the hist plot. Hist plot. Okay. And here we have to consider the salary column, data frame, and our salary column. And beans we will define 30 beans. Okay, and it is a kernel distribution, so KDE equal to true. When I will run this as now, it will show the distribution of salary column like this. Okay, you can modify this chart by giving the title X level, Y level also. The title is given salary distribution, X level, salary, and Y level as count. And running this again, this is our salary distribution. Here we can convert this scientific notation into readable salary values so that we can easily understand this chart. We will use this code plt.ticklabor underscore format, and here we have to set the style as plain x is equal to x. Okay, running this, and you can see that the values are in our readable format now. If we talk about this salary distribution, then this histogram shows how salary values are distributed across the dataset. Here you can see most salaries are concentrated in the lower to mid range only. Also, the distribution is right skewed. It means many people earn lower salaries while fewer people earn very high salaries. Here, these bars are showing the number of employees in each salary range. Here we have 30 bars that we set here, means equal to 30. And on x-axis we have the salary values, while on y-axis we have the count of records. And it is a smooth line here, you can see, because we have set the KDE as true. It is showing the overall salary trend and the distribution shape. Now moving to the main part of this project, answering the business questions. The first question is, which job roles have the highest salary? First of all, have a look at our data set. In this data set, we have the column job roles. So we have to consider this column. It is asking which job roles have the highest average salary. First see how many job roles are there. So we will consider the job roles column. So as you can see, there is space between two words here. So we can't use the dot syntax here, we have to use the square bracket here to consider this column like this. We have to consider job role column, and let's see first how many unique values are in this column. It is showing an error, job role. Okay, so okay, the exact name is job roles, so we have to write roles here. We have 11 unique job roles. Let's see what are these 11 job roles. So again, we will consider this column, and this time we will use the unique function. So these are the different job roles here: Android, backend, database, frontend, iOS, and so on. We have to check out the average salary for each job role. For this, we will use the group by function to make the group of each unique job role. We will do group by on our data frame, and we have to consider our column that we want to use. We want to use the job role column. Okay, so we will consider the second column as salary column. Okay, and to find the average salary, we will use the mean function on it. Suppose I run this now. It will show all 11 job roles and with their average salary. The average salary for Android job role is this much, while the average salary for iOS job role is this much. We can sort this output in ascending or descending order. And to sort, we will use the sort values function. Dot sort values, and here we have to pass one parameter ascending equal to, you can pass it as true or false. We are passing it as false. Okay, and running this again, it will show the highest value at the top while the lowest value at the bottom. Here you can see that the database job role have the highest average salary, while the web job role have the lowest average salary. And we can check the top 10 using the head function on it like this. These are the top 10 job roles with highest average salary. You can save this result in any variable. I am naming the variable as job salary only. Okay, copy this and run this again, and this is our result. Now we will visualize this output in the form of a bar chart. plt.figure, as you all know. Next, you have to consider this output, job salary now, and on this we have to use the plot function. Inside the plot function, we have to pass what kind of chart or graph we want. We want a bar graph, so I will pass kind equal to bar here. Now you can give the title, X label and Y label, and running this, it is showing error plt.y label. Okay, you can modify this chart as well. You can give different color to the bars of your choice. Here you can see database have the highest average salary, Python has the lowest average salary in these 10 job roles. On x-axis we have job roles, on y-axis we have average salary. Now before moving ahead, let's cross check one important thing, and this thing is whether the outliers are removed or not. Okay, just focus on this. Here we checked for the outliers, and there was an outlier here that we removed using the IQR method. But what will happen if I run this code again now? I will copy it and paste here, and so when I will run this, you can see after IQR method it is still showing the outliers. Okay, now we have to remove these outliers as well. So again we will run the IQR method. I am running these code, simply running, okay, like this. And here before, after removing that one outlier, we had 21,614. But when we are removing the outlier again using IQR method, let's check how many rows are left here. You can see we have only 21,014 rows. Means the remaining outliers are also removed now. Now if I again copy and paste this and run this again the third time, you can see there is no outlier now. So finally the outliers are removed from this salary column. So this thing you have to keep in mind. And after removing the outliers, we can run this univariate analysis again. Here the value is 175. Okay, and after running it now, the value is changed to 160. And we can also run the code for our question number 1 again, and this much. Here you can notice earlier the average salary for database job role is 745, but when I run this now, it is changed to 702. Okay, means there are some little changes. And again we have to run this bar plot, and so this is our final answer for the question number first. Moving to the question number 2, which cities offer the highest average salary? Just have a look. This is the data set. Here we have to consider the location column and the salary column. This question is somehow similar to the above question. In the above question, we were considering the job roles column, but here in this question, we have to consider the location column. You can try this question on your own. So first of all, we will group by the location. Our data frame dot group by function, and here we have to choose location column. Okay, and we have to find out the highest average salary. We have to consider our second column, salary. Okay, and like this we will consider the salary column, and for average we will use the mean function on it. Now when I will run this, it will show all the locations and the average salary with respect to each location. Now we can sort this output in ascending or descending order using the sort value function. Sort values. When I will run this, by default it will sort in ascending order. As you can see, lowest salary is at the top and the highest salary is at the bottom. If you want to sort in descending order, you can pass the parameter ascending equal to false. Okay, so Mumbai offers the highest average salary while Madhya Pradesh offers the lowest average salary as per this data set. Now we can save this output in any variable name. I am naming the variable as city salary. Okay, you can give any name of your choice. Running this, and this is our output. We can also draw a bar plot to show this result. And to make this video shorter, I am copying the above code here and paste here. Here we will make the necessary changes. The figure size will be same 8 by 5, and here we will replace this job salary with city salary. Okay, and the plot will be our bar chart only. Here the title, we can change the title top 10 cities, or you can say locations by average salary, and on Y level we will have the average salary. Now we will run this. Here you can see this is the bar graph, top 10 cities by average salary. Mumbai showing the highest bar and Madhya Pradesh showing the lowest bar, and these are the average salary on Y axis. And to make this chart more attractive and readable like this, I have added colors, the grid lines and better formatting to this chart, and the code for this is here. Okay, here I have increased the size of the figure to 10 by 5. Next we have given color to this bar using the Seaborn library, and this is the code. And in next line we have draw the bar chart, and the colors are here from colors, which is this one, and edge colors are black. Edge colors means this boundary, you can say. If I put this as blue, then you can see that the color of the edges is changed now. Next, this is the title, same, and I have increased the font size of the title to 15, this much, and font weight, you can say it is in bold characters now. On X level we have cities, on Y level we have average salary. Next, here we have set the aesthetics. The rotation is set to 45 degree and the horizontal alignment is set to right. And this is Mumbai, Bangalore, Jaipur. These are the aesthetics. Okay. Next, we have set the grid to this bar chart, Here the line style is, you can see, double hash. The next parameter here is alpha, which is used to set the transparency of these lines. You can see these dashes line. If I set the alpha 1, the lines will become more visible, but by default I will set it as 0.5. And next is plt dot tight underscore layout. It is used to automatically adjust the spacing between plot elements so that nothing gets cut off from the graph. Moving to the next question, question number 3. And here we have to name those 5 companies that are located in New Delhi area and where the companies have rating of 5. And we have to tell the top 5 companies that offer the highest salary and top 5 companies, or you can say bottom 5 companies that offers the lowest salaries. Okay, so let's have a look at our data frame. This is our data frame. First of all, we will filter out those companies that are located in New Delhi and have the rating of 5. So we will use the location column and ratings column, this one. First consider the location column, data frame, location. Next we have to pass the New Delhi. Okay, it will filter out location New Delhi. And the second condition is the rating of 5. So we will use the AND operator and put our second condition. Second condition is rating. We will consider the rating column. Here the rating should be 5. Now this is our first condition. After the AND operator, this is our second condition. To get the output, we will put the data frame and the whole syntax in square brackets. When we will run this, you can see these are the companies where location is New Delhi and the rating is 5. Okay, and there are total 137 companies. Now we will find out the top 5 companies and bottom 5 companies. For this, we will simply sort this result with respect to the salary column. Okay, now I will use the sort value function here. On this sort values, inside this our first parameter is by which column we want to sort out the data frame. I want to sort out with salary column, so I will pass salary here. When you will run this, it will sort the entire data frame with respect to salary column in ascending order. Okay, lowest salary at the top and highest salary at the bottom, but in general we want the top salary at the top. Okay, so we will give another parameter which is ascending equal to false. It will sort the data frame in descending order. Okay, now we have the top 5 companies having the highest salary and bottom 5 companies having the lowest salary here. Okay, so these are the company names, top 5 and bottom 5. For your use, you can save this output in any variable. I am naming the variable as df1 only. Okay, and this is my df1. Now in case you want to copy these company names, if you try to copy from here, you can't copy directly, so you can take out these company names only from this data frame, our data frame. Okay, df1. Here I will consider only one column, company name. Okay, on this column we will find out the, or you can say get out the top 5 companies only, so I can use head function here. By default it will show top 5 prem till path universal, but here also you can't copy it. You can convert this output into a form of a list, so you can use the list function here like this. Now you can simply copy and paste this anywhere you want, and similarly you can get the bottom 5 companies from this data frame. Here instead of the head function you have to use the tail function. By default it will show the bottom 5 companies like this. Okay, here you can see Neo Fitness and Atomate. From here Neo Fitness till Atomate. So this is the final output of our question number 3. If you want to learn data science, you can enroll in our Udemy courses. Our first course is about 13 projects and it is among the top rated courses on Udemy. Second course is Python for data science and our third course is NumPy for data science. The link for these 3 courses are given in the description of this video. Moving to the next question. Question number 4 is, which job title has the highest number of salary reported? Let's have a look at our data frame. In this we have to consider this job title column. Here it is asking that how many people related to any particular job title reported their salary. Here, for example, web developer, the salary is reported is 1. Again, for web developer, but the company is different, the salary is reported is 1. Means we want to total these number of salary reported for each particular job title. To get the answer of this question, we can mainly use two methods. First one is very simple. I am telling you about value count function. For this, you have to consider this column job title, and you have to use values count function on it like this. Run this. Here we can notice that this job title software development engineer has the highest number of salaries reported. 2137 people, or you can say 2137 software engineers reported their salary in this data frame. And next is Android developer. Here we have the count 1983. So this is the answer or output for this question. Next, we can also use the group by function, the alternate method, to get the answer. First, we will make the group of each unique job title using the group by function. So data frame and group by function. On this, we have to choose the job title column because we want to make the group of every job title. And here, second column, we have to consider the salaries reported from here. Okay, you can see this one. And here we want the count, so I will use the count function. When you will run this, it will show the output like this. You can sort this output using the sort values dot sort values and run this. You can sort this in descending order using the parameter ascending equal to false like this. So this is the same output. Okay, here software development engineer have the highest number of salaries reported. Moving to the next question. Question number 5th is, which top 10 companies provide the highest average salary when at least 20 employees have reported their salaries? This question can be look tricky to you, but it is simple. Let's have a look at our data frame. Here we have to consider the salary column to find the highest average salary, and the second condition is when at least 20 people have reported their salaries. So here we have to use this column as well as a condition, and we have to filter out those records where the value is greater than or equal to 20 because it is asking at least 20 employees have reported their salary. So first filter out the records where salaries reported is greater than or equal to 20. So I will copy this and paste here, and as per our condition the value should be greater than or equal to 20. When I will run this, it will show the result in Boolean format. To get the output in desired format, we have to pass like this. These are the filter records where we have salaries reported greater than or equal to 20 only. And there are total 157 records. Okay, this is our condition fulfilled. Now we can save this like filtered df for our reference. Copy this, run this, and this is our filter df. Now we have to find out the 10 companies with the highest average salary. For this we will use the group by function. On this filter data frame dot group by, and we will group the company's name. Group by, and here company name. It will make group of all unique companies. Next we have to find the salary, so we will use the salary column in the square brackets, and we have to find out the mean, so we will use the mean function. When we will run this, it will show the output like this. Now we will sort this output using the sort values function, and here ascending equal to false, and as we have to tell the here in the question top 10 companies, so we can use the head function and put 10 in it. It will show the top 10 only, and this is the output. And if you show the top 5, then this is the output. Okay, but we have to tell the top 10 companies. These are top 10 companies: Expedia Group, Nokia, and all. Okay, so this is the answer of this question number 5. Moving to the next question. Question number 5 is we have to check out and show the relationship between the ratings of the company and salaries offered by the companies. This is our data frame. We have to consider the rating column and salaries column, and we have to find out the relationship. So to find the relationship, we can use the correlation function on this data frame, df dot correlation function like this. It will show the correlation between all numerical columns of this data frame. In this output, we have all three numerical columns, rating, salary, and salaries reported. We have to consider the rating and salary column. Here you can see the rating column is not highly correlated with the salary column. It means it is not necessary that if the rating of the company is good, then the company is offering the high salary, and vice versa. We can also check the relationship between two columns only. First, consider the rating column and using the correlation function on this, and in this we have to consider our second column, which is salary. When we will use this, it will show the correlation directly between these two numerical columns, and it is 0.24. Next, in this question, we have to show the relationship. So we can use the Seaborn library for this, and from Seaborn library, I am using a rel plot here. Okay, here on x-axis we can put rating column, on y-axis we can put the salary column, and the third parameter here we have to pass our data. We have to consider this data frame like this. We can use plt.show, and running this, it will show the relationship between the salary column and rating column. From here we can notice if the company rating is only 1, then the salary may be high, and even the company rating is 5, the salary may be low. We can also modify this plot if you need. Then this is the code for this. Here from Seaborn library, I am using the regression plot on x-axis. Let's run it first, and this is the plot. On x-axis we have the ratings, on y-axis we have the salary. The data set here is our data frame, and the some keywords for scatter plot, we have passed the alpha, means transparency of these dots, as 0.5. The color is set to teal. You can set it as red, blue, black as per your choice. And here we have also a line. You can see this blue line is the trend line, which shows the overall relationship between the ratings and salary, and here the line width is set to 2. Next, we have set the title for this plot, rating versus salary, and x label, y label, and the layout is set as tight layout. Okay. Moving to the next question. Question number 6 is, does employment status affect the salary? Okay. And this is the data frame. Here we have to consider the employment status and the salary column. Let's first check how many different employment status are there. We will consider this column, employment status, and on this we will use the unique function. Here you can see we have full-time, intern, contractor, and trainee. We have to check out the salary based on this employment status, whether the salary is low or high. Let's first check the number of employees belonging to each employment status using the value count function. On this column, I will copy this and paste, and on this I will use the value count function. It is showing an error. It is value. Okay, so mostly we have full-time employees, then we have intern, then contractor, and we have only 33 trainee. We can check the salary statistics for each employment type also, such as mean, minimum salary, and maximum salary, using the describe function. First of all, we will group by all employment status, and okay, and we have to consider the salary column, and we have to use the describe function. Here you can see for each employment status, it is showing the count, the mean, standard deviation, minimum, and percentile and maximum salaries. Here we can notice that full-time employees are getting the maximum average salary, while trainee are getting the lowest average salary. Now we will visualize this using a box plot to better understand the distribution and the outliers. First, set the figure size using the figure function. The size of the figure is set as 6 by 4. Now using Seaborn library, we will draw a box plot. SNS.boxplot. On x-axis, we will keep employment status, and on y-axis, we will keep the salary. So y equal to our salary column here, and our data set is stored in df. Okay, now we will write plt.show, and this is the box plot. We can set the title, the x label and y label for this box plot. The title is given employment status versus salary. On x-axis we have employment type, and on y-axis we have the salary. And running this, we have the title, x label and y label. In this plot, the values on y-axis are in scientific notation. We can convert it into simple numbers, and for this we have to use Matplotlib library plt.ticklabel_format function, and inside this we will pass the parameter style equal to plain. Okay, now x is equal to y. When I will run this, it will show the numbers like this. From this plot, we can notice the median salary for each employment type by this line, which is shown inside each box. Here, full-time employees have the maximum median salary, and then we have the contractor, slightly lower median salary, about 4 lakh. Then we have the interns, about 2.5 lakh, and at last, the lowest median salary is for trainee, which is about 2 lakh. And this median salary is also mentioned here using the describe function. Here 4 lakh, 5 lakh, 2.6 and 2.4. Next, we can notice the salary spread, which is represented by the height of the boxes. Here, the full-time role employees show the widest spread, meaning the salaries varies a lot for full-time employees. Next, for contractor roles, also there we can see significant variation in the salaries, while intern and trainee roles have more concentrated lower salaries. Next, if we talk about the outliers here, then we can see all categories have high salary outliers. Especially the outliers are visible in interns and contractor roles, which shows that a few people earn unusual high salaries, as we can notice from here also that maximum salary for these roles are much higher than their average salary. Finally, we can say that the full-time roles generally offer the highest salary, while interns and trainees earn very less. Okay. However, the presence of outliers in this box plot shows that exceptional cases exist in every employment status. Now, in case of interview, if someone asks about this box plot, then you can say that these boxes represent the middle 50% of the data, and this line in each box is the median, and the upper line, this one, and this bottom line are the whiskers that represent the normal range, and these black dots represent the outliers. Moving to the next question. Question number 7 is, which job role are the most common? Let's have a look at the data frame. In this data frame, we have to consider this column, job roles. In simple words, the most common job role will be that which is occurring most of the time in this column. And to find the occurrence of the values in a column, we use the function value counts function. So on this column, job roles, we can use the value counts function to check the occurrence of each element present in this column. By default, it will show the result in descending order. Here you can see SDE, Software Development Engineer, is the most common job role here, and the occurrence here is 7,245. Then we have Android and front end, and at last we have the least common job role, mobile, which is 211 only. Now let's draw a horizontal bar chart to represent this output. We will consider the top 10 job roles only. So first of all, I will copy this and save this in any variable. Suppose I am naming it top roles. Okay, you can give any name, paste here, and from this we will consider only top 10. So I will use head function and 10. Top roles, we have 10 top roles with their counts. Okay, first of all we will set the size of the figure. The size of the figure is set to 10 by 6. Next, using the Seaborn library, we will use the gradient colors, and using SNS, here we have color underscore palette, and here this time palette I will set as HSV, which will show a rainbow effect. Next, we have to pass the length for this palette, and the length will be equal to the 10 because we have 10 job role. So I can simply pass top roles here. It will automatically count the length as 10. Okay, we can save this in any variable colors. Next, we will draw the horizontal bar chart, and we will use the Matplotlib library. From this, we will use bar H, means horizontal bar chart. We will take the top rows that we have above, and from this we will choose the index on x-axis while the values of it on y-axis. So top rows dot values. Okay, and the color will be that we have chosen here equal to colors. Also, we can give the edge color to the bars, means you can say boundary or border. You can give edge color of your choice. I am giving the edge color as red. Okay, now if I run this now, let's see how it will look. So this is the horizontal bar chart representing the top 10 job roles with their counts. Here we can modify this. We can add the count or numbers, or you can say value labels on these bars. Here, using the enumerate function, we have set the value labels. This is the code for this. When I will run this, you can see now we have the numbers on each bar. And at last, we can give the titles and labels to this bar graph. The title is given top 10 most common job roles. The font size of the title will be 16 and it will be in bold characters. Running this, and this is our final horizontal bar graph. Here we have some mistake in question numbering. I will correct it. This is the question number 5 and this is question number 5. Okay, so I will make it 6, 7, 8, 9. Okay, like this. Question number 6. Question number 7. And question number 8. Finally, we will have our question number 9. Question number 9 is, how does the average salary change as the company rating increases? Let's look at the data frame again. So we have to consider the salary column and the rating column. First, we will find out the average salary for each different rating. For this, we will use the group by function on the rating column. All different rating will be in separate groups, and after this consider the salary column. To get the average, we will use the mean function here. Okay, and when I will run this, it will show the output like this. Now this output is in the form of a series. If I show you, I will save this in X, and when I see the type of X, you can see it is a series. We can convert it to data frame to visualize this output. So to convert into data frame, we have to simply use the reset index function here at last. Okay, when I will use this like this, it will be converted into a form of a data frame. Now if I show you now X, now type of X, you can see it is a data frame now. So using the reset index function, we can convert the series output into data frame type. Okay, now instead of X, I will use a simple variable rating, and you can say salary. Okay, this is my rating salary, and rating salary dot head we will use to show the top 5. This is how our final output will look like. Now we can draw a line chart to see the trend. First of all, we will set the size of figure. The size of the figure is set to 7 by 5. Now using the Seaborn library, we will draw a line plot. Line plot on x-axis, we will have rating column. On y-axis, we will have the salary column. Okay. And our data will be this one. We will consider this data frame. So I can copy this and paste here directly. Next parameter, we can use marker. I will show you what is this marker, and we can consider it as at last plt dot show. Running this, it is showing an error. The error is we don't have to pass the quotes here for data frame. We have to write it simply. Okay, when I will run this, it will show the line chart. Here you can see on x-axis we have the rating from 1 to 5. On y-axis we have the salaries. We can also modify this line chart using the title, x level and y level. The title here we are setting average salary trend across company ratings. On x level we have company ratings, on y level we have average salary. Okay, and plt dot show again. Running this, this is the line chart. It is noticed from this line chart that there is generally upward trend, means companies with higher ratings tend to offer slightly higher average salaries. The second thing is the ratings between 3 and 4.5 show the most stable and higher salary range. Here we can see 3 from 4.5. Okay, and some ratings show sudden spikes and sudden drops in average salary. And this usually happens because when we have very few data points exists for those ratings. At the end of this project, we will summarize everything in one simple mini dashboard here. In this mini dashboard, we can include our salary distribution, which will be shown by a histogram here. Okay, and we can consider the rating versus salary, and we can consider average salary by rating, that can be shown by a line plot, and we will also consider the top locations by salary. So here we will use two different data. Here first one we will use this data set, rating salary. I am copying this again and paste here. Okay, and second we will use the location versus salary data, and here it is shown in question number. And okay, this much, this one we will consider. I will paste this here again, and I am changing the variable name to top location for better understanding. Top locations. In first step, we have prepared our data, and the first data is rating versus salary. The second data set is location versus salary. Now we will set the size of this dashboard, and plt.figure as usual. The fixed size here, we will give a some larger size here, and for the mini dashboard. Now we will plot our 4 different subplots in this dashboard. Our first subplot will show the salary distribution. So plt dot subplot, here we will write 2, 2, 1. Okay, and we will use the SNS Seaborn library to draw a histogram using the histplot function. Inside this we will use the salary column, and we can give the size to bins as we did above, equal to 30, and it will be a kernel distribution plot. Okay, so we are setting KDE as true, and plt.title, you can give title of your choice. I am naming the title as salary distribution only. Okay, this is our first subplot. Next we will draw a subplot that will show rating versus salary. Again plt.subplot, and this time we will set 2, 2 by 2. Okay, the second subplot, here we will use Seaborn library. From this we will use the scatter plot. Okay, and on scatter plot, on x-axis what we have, we can take ratings, and on y-axis we can take the salary, and here data will be our actual data frame df. Okay, and we will set the transparency of the dots using the alpha parameter, and I am setting the alpha as 0.5. You can say medium transparency. Also, we can draw a regression plot using the Seaborn library and regression plot function. From here, x equal to same rating column, and our y will be salary column again, and our data set here will be original data frame, and this time we will set scatter equal to false, and we can set the color also. This time I am setting the color as red. Okay, mentioning the title of this plot using the title function, and the title can be rating versus salary. This is our second subplot. We will draw our third subplot that will show average salary by rating. For this we will draw a line chart. First of all, we have to use the subplot. I am copying and paste here, and we will make it 3 because it will be our third subplot, and we will use the line plot from Seaborn library. Line plot on x-axis we will have rating column, on y-axis we will have salary, y equal to salary here, and our data this time will be, we will consider this data set rating salary. I will copy and paste here directly. You can use one more parameter which is marker here, marker 0. Okay, and plt.title, the title you can copy and paste here, average salary by rating, and paste this. This is our third subplot. Okay, in our last question I was talking about the marker parameter. Marker, when I set marker this O, you can see this is our marker which is showing by a dot. If I set it as star, you can see that the marker is changed now. Okay, so these are the markers, and so this time I am setting the marker as star only. And now we will draw our fourth subplot. In the fourth subplot we will show the top locations for salaries, and we will use this plt.subplot, and it will be our fourth subplot, so I will use 4 here, and this time we will use this dataset top locations that we used above, top locations, and here we first of all we will sort the values. Then we will draw the plot, and this time we will draw a bar chart, so I will use bar H here. Okay, and you can give color to the bars of your choice. I am giving the color as let's say green. Okay, and we will give the title also. The title is given top 10 location by average salary, and at last we will use one more function plt.subtitle. Here I can give the title as salary data analysis dashboard. The font size can be 18 and font weight equal to bold. BOLD. Okay, and at last we will have to write plt.show. When I will run this, it will show the mini dashboard to us. So this is our salary data analysis dashboard having the 4 subplots. First subplot is for salary distribution, then second we have salary versus rating. Also we have average salary by rating and top 10 location by average salary. So that's how we can draw a mini dashboard for our data analytics project. Here, instead of looking at individual charts separately, we have combined key insights into a mini dashboard. This gives a quick business overview of the entire dataset. So this is the end of our project. Friends, if you like this project, then kindly hit the like button and subscribe to our channel for more projects videos. And here we have one project playlist. In this playlist, as of now we have 13 projects, and we will upload more projects in this playlist. And if you want to learn data analytics with Python by yourself, you can consider our useful notes. These are the command notes, and the link to these notes is given in the description of this video. Here we have Matplotlib, NumPy commands, pandas command, which are mostly used for data analytics. These are the pages, okay, and we also have the SQL commands.